Oh yeah, and this is the absolute next video. So diameter of a binary tree, I've already did this. Given a binary tree, you need to compute the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. Yeah, so in retrospect, oh wait, the length of the path between two nodes represented by the number. Okay. Yeah, so my approach here was to create a function that, given a node, returns the longest path available from that node, or at least one of them, or just not the path itself, but the length of it. And once you have that, you can do so like, okay, what's the, usually it's going to be a fork or a path. The longest fork, that's what I'm calling it in this case, let's say 1, would be 2, 1 plus the longest path of the left node after, and 1 plus the longest of the right. So in this case it would be 1 plus 1 plus 1 more for the 2. And the path from 3 after 3, 4, or 5 is 0. So that matches with the return here. Now, how did I do that? Cool. So again, this is not the most efficient solution. This is very redundant. I added this as some sort of so one optimization is that once you have the longest path from the root, anything that has a path that's less than half of that doesn't have to be computed, because no matter how long it's going to be, whatever fork there is between that, let's say a fork, oh, I don't have my drawing tablet with me. Well, whatever. Damn you. Yeah, so whatever path you get, even if it's a fork, this is not the root, this is just some other, even if you get a fork, that fork can at most be the longest times 2 at most. So once you get to a point where the longests are less than half of the longest starting from the root, you just stop traversing the tree. I used memoization here for doing this. It might actually be more efficient to calculate the distances, saving values onto the nodes. That would be a solution, to be honest. You could do distance from root. Or I don't know. Something, but this works. That's the important part. I'm using depth first search because I thought it was going to be sufficient for doing the exercise. In actuality, it should have. Yeah, it's enough. Breadth first search matches more with the cutoff thing I mentioned, but if you have a tree that has longer in one end than the other, it's the same. So, let's see this logic. Ooh, do I even need this I? Yeah, so this I was just for the purpose of debugging. I do not need this. Okay. Cool. So if there's no root, return 0. And we're going to make furthest leaves as something to memorize the result of this to furthest leaves. Leaf. Cool. So let's do this. So while stack length is above 0, and we initialize the stack with just the root, you pop the stack, get the d is equals longest fork, which in this case, comparing d in diameter, the half-2 thing should actually be the distance. This to furthest leaf, not the longest fork. So this to furthest leaf of root. Actually, yeah, so this is the one that's being memoized. Let's just call this magic length. Magic number const. Magic number equals of root. And let's just if this should might help with the optimization. I'm not sure. I'm just gonna comment and uncomment this line after a bit. So if this to furthest leaf of node, and it's okay to call this multiple times because it's memoized, of n is less than magic number divided by 2, we continue with the loop rather than going with the rest of the stuff. I'm not even going to explain it. I'll get back to it later. So you get the get n, get the longest fork from that. If the longest fork is above the current diameter, set that as the diameter. If it has a length, if it has a left, add that to the stack. If it has a right, add that to the stack. Wait, is this depth first, breadth? It's mixed. I don't care. I'm just array stack. I don't know. Maybe that's what's causing it to be slow. Cool. So let's just go for the helper functions and say what they are. This to furthest leaf is recursive. That's probably also why it's I don't know. Essentially, it returns the longest path of the left or the right. I memoized it for reasons. And longest fork is literally just taking either 1 plus furthest distance in the only direction possible, or 2 plus the distances on both ends, or it's essentially 2 plus the distances on both ends, as long as there's a if there's nodes on both ends. YOLO. Cool. So let's see what's the performance here. So my runtime beats 8.67. That's pretty bad. If I uncomment this optimization, which I assume should bump it up at least a little bit. Nope, it does not. Cool. I guess that makes me look dumb. Continue, break. Cool. I'm tired, to be honest. Like, this is... Yeah, maybe I should get deeper into this, or maybe I should work on learning more back-end stuff rather than just plain old coding challenges, but yeah. It's not the best solution, but it's a solution. I'd go to discussion. You know what? Let's go to discussion. Let's see. Oh, look. 5 lines. OFN solution. Okay. Essentially what I said, but in less words. What is rec? Oh, yeah. Recursive case. If root null. Oh, yeah, it's literally the same thing I did, but different. Wait, is this C++? Root left, root right. Ooh. Is this actually how it's written? I mean, it makes sense for it to just have that there. Oh, this guy says it's not working. Let's see. Honestly, it's the only person that says it's not working. Maybe their implementation sucks. I really don't care. That's essentially... Okay, so I seem to have something redundant here. And the redundancy is probably on the fork part. Yeah, so having the longest fork be a thing. Let's try this again with, yeah, so let's const ld and if this receives a null, cool, so this should work just straight up like this. And Yeah, I have no idea what I'm doing right now. So I'm doing d equals longest fork. Let's make d yeah, so let's just make let d equals 0. And if this d plus 1 plus blah, and then we do the same for the right. And this is redundant. And now move here this blah. And this, and let's see, we don't need this anymore. Wait, we don't need this anymore because I just added the logic inside the main loop. And let's see if it works, which if it doesn't, I'm just going to give up. Oh. Well, I'm still in 7, but I simplified it. Wait. Yeah, I'm just gonna leave it like that. I don't really care what's going on. Like, this is Access Solutions. Wait. Yeah, these are the JavaScript ones, and some people are just faster than I am, apparently, and I don't care. Maybe it has to do with a transform. You know what? I need to find what other JavaScripts Cool, diameter of binary tree. Let what is max? Oh God. Max equals 0, but then max equals something else. I mean, okay. Left, right. I mean, this is the same. You know what? I'm just going to copy this and paste it. I said I'm going to paste it. Yeah, I even used let instead of var, that monster. Yeah, I'm joking. What's the solution runtime of this one? Yeah, so it's way better than mine. Cool, so let's compare what differences mine has with this one. So this is recursive. And this is using an array. And I'm using explicit. I have no idea. I'm just tired. I'm gonna take a break. This is Sunday, and like, wait, it's Saturday. Yeah, that's just proof that I'm not perfect, I guess. So let left one go. Yeah, I'm just gonna stare at this for a bit and then call it quits. I feel that recursive solution is pretty nice, to be honest. Way better than my crap. So go. Oh God. Go traverses. And the. Okay, so it recurses onto itself here and returns the max left and right. While calculating the max. What am I doing wrong? Is it the stack? Is it because I'm using an array? I do not know. So this is recursive, just the furthest leaf. Yeah, this feels like it should work. Like, is memoization just not happening? Like, furthest leaves? Like, is a memoization even necessary? You know what? I'm gonna get rid of the memoization. Just see how that fares. Oh, it's slightly better without it. Maybe the fact that I'm using the array isn't helping me somehow. I don't know. Do I need the stack? Can I just do it all recursively? I don't care. This is Jose banging his head against the wall again and again and again and again until it gets better.